Hello students, in today's video we are going to solve Cambridge O-Levels Additional Mathematics Paper 2 in a session May-June 2021 Paper 2-2. So let's start with the first question. Question number 1, using the binomial theorem, expand this expression, simplify each term. So the power is 4, so we can say that this is 1 power 4 plus 4c1 1 power 3, the second term e power 2x power 1 plus 4c2, 1 power is again reducing by 1, that is 2, and e power 2x power increasing by 1, that is q, plus 4c3, 1 power is 1 and e power 2x power is 3, plus 4c4, 1 power is 0 and e power 2x power is 4. Okay, so 1 power 4 is just 1. What is 4c1? Let me check. 4c1 is 4 plus this is 4 e power 2x plus 4c2. 4c2 is 6. 6 e power 2 times 2 is 4x plus 4c3. 4c3, that is equals to 4, and this is e power 2 times 3 is 6x, and 4c4 is I guess 1. Let me check. 4c4 is 1. Yes, so we have plus e power 4 times 2 is 8x. Question number 2, on the axis, sketch the graph of this function stating the intercepts with the coordinate axis. So you can see this is the polynomial function in factored form, right? So first thing we need to check to graph this polynomial function in factored form. First we have to find the degree of that polynomial function. Okay, so as you can see here, x power is 1, 1, 1. So the degree is 3. So we can say that this is odd degree polynomial function. Right. Now the second thing, we need to find the end behavior. End behavior means the graph extend from which quadrant. So when the degree is odd, it has opposite end behavior. So opposite end behavior means the graph extend from first to third quadrant or second to fourth quadrant, depend on the sign of the leading coefficient. So what is the leading coefficient over here? Leading coefficient is 3, right? So this is positive. So we can say that leading coefficient is positive. So when the leading coefficient is positive, so we can say that the graph extends from first to third quadrant. Right. Okay, now the next thing we need to find the zeros, or we can say the x-intercepts. Number 3. Zeros or the x-intercepts. To find the zeros, we need to put all the 3 factors separately equals to 0. We will get the zeros. So x minus 3 equals to 0, x minus 1 equals to 0, x plus 2 equals to 0. So the zeros are 3, 1 and minus 2, right? So we can say that x is equals to 3, x is equals to 1, and x is equals to minus 2. These are the zeros. Now the fourth step is the y-intercept. So y-intercept is a point where the variable x equals to 0. So y is equals to 3 times, just put x equals to 0 throughout the equation, minus 3, minus 1 and 2, right? So let me simplify. Negative times negative is positive. We have 2 times 3 times 3, that is 18. 18 is the y-intercept. Right. So now we have the x-intercepts, we have the y-intercept, and we know that the graph extends from first to third quadrant, right? Now let me use the scale that is, let me label the points. So this is 1, minus 2, minus 3, minus 4, and here we have minus 5. Okay, now on this side we have x equals to 1, 2, 3, 4, 5, and the y value, let me check the y's as well. No, for the centimeter, yes. 1, 2, 3, 4. Okay, so we have the x-intercepts. As you can see, the zeros are 3, 1, and minus 2. So here we can say that we have minus 2 is here, 1, 2, 3, 4, 5, minus 1, minus 2, minus 3, minus 4, and minus 5. So let me label the zeros first. That is minus 3. We have 3, 1, and minus 2, not minus 3, right? And the y-intercept is 18. So the scale for y is 5, 10, 15, 20. So 18 lies somewhere here, that is closer to 20, right? That is my y-intercept. Okay, and we also know that the graph extend from the first to the third quadrant, right? This is the first and this is the third quadrant, right? So let me draw the graph that passes through the x-intercepts, the y-intercept, and this. So as you can see, the graph passed through all the three x-intercept and the y-intercept. So this is going to be the graph for the given polynomial function in factored form. Question number 3, find the values of the constant k for which this has a real root. Okay, so if it has a real root, it means the discriminant is greater than equals to 0. For real root, it is greater than equals to 0. So we have a discriminant b square minus 4 times a times c. So this equation look like the quadratic. So a is the coefficient of x square, b is the coefficient of x, and c is the constant term, right? So let me solve this discriminant that is greater than equals to 0, right? So let me substitute the values here. B is 6 square minus 4 times the a value is 2k minus 1 times the c value is k plus 1, that is greater than equals to 0. 6 square is 36 minus 4 is outside. Let me multiply the terms. 2k times k is 2k square plus 2k minus k minus 1 is greater than equals to 0. So we have 36 minus 4 into 2k square plus k minus 1 is greater than equals to 0. Here we have 36 minus 8k square minus 4k plus 4 is greater than equals to 0, or 8 minus 8k square minus 4k, 36 plus 4 is 40, is greater than equals to 0. Dividing with minus 4 throughout the equation, 4 times 2 is 8, so 2k square plus 2k, plus k, because we're dividing with 4, and then 4 times 10 is 40, is greater than equals to 0, right? So we have an equation 2k square plus k plus 10 is greater than equals to 0. So that is a quadratic equation. Let me solve, factorize this. 2 times 10 is 20. So let me use a quadratic formula over here. If I consider this as 2k square plus k plus 10 is equals to 0. So k is equals to minus the b term plus minus k root. B value is 1 square minus 4 times the a value times the c value, divides 2 times of a value, that is 2. right? So further simplification, we have minus 1 plus minus square root. 1 square is 1. 4 times 2 times 10. 4 times 2 times 10 is 80. Minus 80. Sorry, when we took negative sign common, dividing with minus 4, we will get minus 10 here. So this is minus 10 and minus 10. This is positive of 80. Divides 4. So this is equals to minus 1 plus minus square root of 81 divides 4, and square root of 81 is 9, right? So the k value we can say is minus 1 plus minus 9 divides 4. Okay, let me solve one by one. Minus 1 plus 9 divides 4. Minus 1 plus 9 divides 4. That is equals to 2. From here, k is equals to 2. And minus 1 minus 9 divides 4 is minus 2.5. Okay, now let me substitute this back into this equation. Oh, and one more thing, when we divide this inequality with negative 4, we have to change this inequality. That is a mistake we did. Less than, greater than, equals to changes to less than, equals to, right? Okay, so now we have k minus 2 is one factor, and k minus plus 2.5 is less than equals to 0 is another factor, right? Okay, now if we can see, if we have this quadratic equation, if I can write it down again, 2k square plus k minus 10 is less than equals to 0, right? So this is a quadratic look like a quadratic equation in k. So as you can see, the k square coefficient is 2. It is positive. It means the opening of parabola is upward, right? And we have two k values. We have minus 2 over here and minus 2.5. K value is minus 2.5 and 2, right? And this is the shape of the parabola. Its opening is upward because the k square coefficient is positive, right? Now we need to find the values of k when it is less than equals to 0. So it is less than equals to 0. The negative portion is downward when the k value is between minus 2.5 and 2. So we can say that the inequality is going to be minus 2.5 is less than equals to k is less than equals to 2. So these are the values of constant k for which the given equation has a real roots. Question number 4, the polynomial p of x where m and n are constant has a factor 3x minus 1. So if it has a factor, so it means p of 1 by 3 is equals to 0, and a remainder of 6 when it is divided by x minus 1. This means that p of 1 is equals to 6. Show that x minus 2 is a factor of the polynomial. So first, by using the given information, the two information, we have to find the values for m and n. So the first is we need to do p of 1 by 3 equals to 0. Right, so what is p of 1 by 3? Just substitute x equals to 1 by 3. So m 1 by 3 cube minus 29 1 by 3 square plus 39 1 by 3 plus n equals to 0. Right, let me simplify. This is m divides 27 minus 29 divides 3 square is 9 plus 39 divides 3 plus n equals to 0. Right, so further simplification, m divides 27 plus n, and what are the constant terms? Constant terms are 39 divides 3 and minus 29 divides 9. That is 88 divides 9, the positive sign. 88 divides 9 equals to 0, right? So 27 is an LCM for this. So let me divide throughout 27 and multiplying with 27 with 0, that is equals to 0. So m plus 27n, and what is 9 times 3 is 27, and 3 times 88 is 264. So plus 264 equals to 0, or we can say that m is equals to minus 264 and minus 24n. This is my first equation. I got the value for m here. Now using the second information, we have p of 1 equals to 6. Let's do this. When p of 1 equals to 6, so just substitute the variable x equals to 1 here. So we have m 1 cube minus 29 1 square plus 39 1 plus n equals to 6. So here we have m minus 29 plus 39 plus n equals to 6. So here we have m plus n equals to 6 plus 29 and minus 39, right? Okay, so we have 6 plus 29 minus 39, that is negative 4. So m plus n equals to minus 4. This is my second equation. So as you can see from the first equation, we got the value for m. Just substitute that m value into the second equation, that is minus 264 minus 24n plus n equals to minus 4, right? So the variable n is minus 24 and plus 1, that is minus 23, and here we have minus 4 and plus 264, right? So minus 23n equals to 260. From 264 subtract 4 is just 260, right? Sorry, this is m is, when we shift here, this is not 24, this is 27 here, and when we substitute this value, we have 27 here and 26, so n value is minus 10. So 260 divides 26 is minus 10. Now substituting this n value over here, and we will get the m value. So m is equals to minus 264 minus 27 times minus 10, right? So this is minus 264, minus times minus is plus 270, yes. Okay, so from 270 take away 264, that is 6. So we can say m is 6 and the n value we got is minus 10. Now let me substitute the values for m and n. We will get the polynomial p of x, that is mx 6x cube minus 29x square plus 39x plus the n value, that is minus 10, right? Now we have the question that showed that px minus 2 is a factor of this polynomial. So x minus 2 is a factor. It means when we put p of 2, we must get equals to 0, right? So let's see what is p of 2. So p of 2, 6 times 2 cube minus 29 times 2 square plus 39 times 2 minus 10, right? Let me simplify this. So 2 cube is 8 times 6, that is 48. So this is 48 minus 29 times 4, 116. 39 times 2, 78, and minus 10. Okay, this must be equals to 0. Let's see. 48 minus 116 and plus 78 and minus 10. This is equals to 0. Yes, so we can say that yes, the x minus 2 is the factor for the given polynomial. Question number 5. The function f is defined for x is between 0 degree to 810 degrees by f of x equals to this. It is a cosine function. For a part, write down the amplitude of f. So we can say that amplitude is absolute value of a, that is equals to 1 in this case. So if I rewrite this as y equals to a cos b x minus d plus c. So we have here f of x is equals to a is 1 cos 2 by 3 x minus 0 minus 2. So the a value is 1, right? Okay, now for the b part, find the period of f. So as we know that the function is cosine, and the period for the cosine function is 360 degree. So the period is 360 divides the b value, right? So we have 360 divides the b value is 2 by 3, right? So we have 360 multiply 3 by 2, the reciprocal of 2 by 3, right? So let me simplify this. 2 divides 3, sorry, 3 divides 2, multiply 360, that is 540 degree is the period for this sinusoidal function, right? Now for c part, on the axis sketch the graph of y equals to f of x. We need to graph this function. Amplitude is 1, b value is 2 by 3, phase shift is 0, and equation of x is the c value is minus 2, right? So to graph this function we need some steps. So let me write down step by step. Okay, let me rewrite this as f of x is equals to 1 cos 2 by 3 x minus 0 minus 2, right? So the first thing is we need amplitude. Amplitude is the a value, absolute value of a, that is equals to 1, right? Then I need equation of x's. Equation of x's is the c value, so c is minus 2. So with the help of amplitude and equation of x's, we can find the maximum point of this curve and the minimum point of this curve. Maximum value and the minimum value. So the maximum has a formula c plus a, and the minimum has formula c minus a. So c is minus 2 plus 1, and here minus 2 minus 1. Here we have minus 1 is a maximum point and minus 3 is a minimum point for this curve, right? Okay, the fifth thing is the period we just got in the b part, that is equals to 540 degree. The one complete cycle for this curve is 540 degree. Okay, now the next is we need distance between points. So distance between points has a formula, period divides 4. So we do 540 divides 4. So 540 divides 4, that is 135 degrees. Okay, number 7 point, we need phase shift. Phase shift is the d value. So as you can see, the d value in our curve is just 0. You can see that this is 0. So we have the phase shift is 0. Right. Now let me write down the x coordinates. So keep in mind x coordinate starts with a phase shift, and we need to add distance between point each time. So the first coordinate is a phase shift, that is 0, and the next is adding distance between points. So in 0 we add distance between points, so this is 135 degrees. In 135 again add distance between points. Let's see, 135 plus 135, that is 270. In 270 add 135. Each time I add distance between points, right? 405, 405, add 135, 540, one complete period. But the domain we have given, as you can see, is, let me show you, that is 810. So we have to go forward. Let's see the rest of the points. In 540 add 135, 675 at 135 plus 135 is 810. Yes, now we have to stop here. Right, 0 to 810. So these are the x coordinates. Now what are the y coordinates? Okay, let me explain you how to get the y coordinates. If I draw the curve here, yes. So this is a cosine curve, and we know that the curve of cos x always starts with the maximum point. This is the curve for the cos x, right? So this point is the maximum. This point is the c value, the equation of x's. This is the minimum point, then the c value, and then again the maximum point for one complete cycle, right? Okay, so the first y coordinate is a maximum point, and we have the maximum point that is -1 and the minimum is -3, and equation of x's we have is -2, right? So let me write down the coordinates now. So for here, this is going to be x coordinate is 0 and the y is the maximum, that is -1, right? Here we have 135 degrees and the equation of x's, that is -2, right? So 275 degrees and then the minimum point -3, right? 405 degrees and again the equation of x is -2, 540, and the maximum point is -1, right? Okay, and 675 degrees, and then again it goes to equation of x's, that is -2, and then 6 from equation of x's go to the minimum point, 810, and the minimum point is -3. So these are the coordinates, right? Okay, now let me draw this curve. So this is our coordinate axis. So the first we can say these are the points 1, 2, 3, 4, 5. So y values are all negative. So we can say this is -1, -2, -3, and -4, right? So as you can see, the first point is 0, -1. When x is 0 degree, the y is -1, this point, right? The next is 135 degrees and -2. So where is 135? 135 is between 90 and 180, right? And this is -2. So this is going to be the point, right? Then 270 at -3. So for -3, we have 270, right? And 405, and for -2, again for -2, 405. 405 is over here between 360 and 450. Okay, the next point is 540 at -1. So 540, this is -1, y is -1, and 675 -2. 675 is between these 2 points as -2, and the last point is 810 at -3. 810 at -3, right? Now let me connect all these points to get the smooth curve of this cosine function, the sinusoidal function. Question number 6. The points A, that is 5, -4, and C, that is 11, 6, are such that AC is diagonal of a square ABCD. So ABCD is a square and AC is the diagonal of a square, right? Now for A part, find the length of the line AC. Okay, so for length of a line, we use the formula, the distance formula or the length formula, that is square root of x2 minus x1 whole square plus y2 minus y1 whole square, right? Now let me substitute the values, the x1 y1 x2 y2. So length is going to be x2 minus x1. This is x2 and this is x1, so we can say that 11 minus 5 whole square plus 6 minus 4, that is plus 4 whole square, right? So 11 minus 5, 11 take away 5, that is 6 square, 36, and 10 square is 6 plus 4 is 10, that is 100. So 36 plus 100 is 136, and what is square root of 136? That is equals to 11.66, or we can say 11.7. So the length of a line AC is 11.7. Now part B, 1. The coordinates of the center E of a square are 8y. Find the value of y. Okay, so we have given that ABCD is a square. Let me draw this square. All the four sides are same. So this shape look like a square. Let's say this is A, B, C, and D, right? So AC are the diagonal, right? AC is the diagonal, and we need to find the center point, that is E. So we need to find the midpoint of AC, right? And that is 8y, right? So midpoint formula, we have midpoint of AC is x1 plus x2 divides 2, and y1 plus y2 divides 2, right? So the midpoint is 8y equals to A and C we have given 5 and 11. 5 plus 11 divides 2, and minus 4 plus 6 divides 2. Okay, so what is 5 plus 11? 5 plus 11 divides 2, that is 8. So x coordinate match with this 8y, and this is equals to 8, and the y coordinate is from 6 take away 4, that is 2, 2. This is 1. So we can say that the y value is 1, right? So the value of y is equals to 1, right? Now for the second part, find the equation of diagonal BD. Okay, so we have the other diagonal is BD. We need to find the equation of this diagonal. Okay, so as we know that the diagonal of the square are perpendicular to each other, right? So basically we need to find the equation of perpendicular bisector of AC, that is the line diagonal BC. So we need to find the slope of AC and do its convert the slope as a perpendicular, because AC is perpendicular to BD, because diagonals are perpendicular for a square. So the slope is y2 minus y1, so 6 plus 4 divides x2 minus x1, 11 minus 5, so that is 10, and 11 take away 5 is 6, 10 by 6. 10 divides 6, that is 5 by 3, right? Or we can say the slope of BD is perpendicular, that is minus 3 by 5, and we have the midpoint AC as well. So we use this slope and the midpoint to find that equation, right? So we have equation y equals to mx plus b, right? So y equals to m value we have is minus 5 out of 3, minus 3 by 5 x plus b, and to get the value for b we use x equals to 8 and y equals to 1. 1 equals to minus 3 by 5 into 8 plus b, right? Okay, now let me simplify. We have 3 times 8 divides 5 times okay, now shifting this term over here, it is positive, right? So answer plus 1, that is my 29 over 5 is the b value. B equals to 29 over 5, right? So now we can say that the equation of diagonal BD is equals to y equals to minus 3 by 5 plus x and plus 29 by 5. This is the equation of diagonal BD, right? Now for the third part, given that the x coordinate of B is less than the x coordinate of D, right? So this information we have given. Write EB and ED as a column vector, right? Okay, to get the value for EB and ED, we have the vector E, but we have to find the vector B and the vector D. Okay, so as we have given that ABCD is a scale and AC are the diagonal, A coordinates and C coordinates we have given, and the midpoint of AC is E, that is 8, 1. So if I draw these coordinates onto the grid, let me use the grid here. So we have the A is given to us, that is 5 and minus 4. So X is 5 and the Y is minus 4. So we have 1, 2, 3, 4, 5 and minus 4 downward, 1, 2, 3, 4. So this is a point A, right? And the point C is 11, 6. Okay, X is 11 and Y 6. So X is 11 here and 6, 1, 2, 3, 4, 5, 6, this point. Okay, let me connect these 2 points because these are, see, these are the diagonal of the scale, right? And we have given that the midpoint of AC is E, that is 8, 1. So as you can see, the midpoint is 8, 1. X is 8 and Y is 1. 1, 2, 3, 4, 5, 6, 7, 8 and Y is 1 at the top. This is the E, right? So now as we know that the diagonals are of a scale are perpendicular to each other at 90 degree, so we need to draw the perpendicular line. Let me draw the exact perpendicular line, the line that is perpendicular to this line AC, right? So let me draw the line that is perpendicular to AC like this. Let me do this. Okay, so it must be perpendicular, so we can say that, let me draw this, and it must be a scale. Let me connect this point with the C. Yes, so as you guys can see, this diagonal is, this is a perpendicular line. Okay, so what are the coordinates for B? This, let's say this is B, because we have given that the x coordinate of B must be less than the x coordinates for D. So B must be here and D is over here, right? Let's say this is D. So this point is X is 1, 2, 3 and Y is 1, 2, 3, 4. So this is B. Its coordinates are 3, 4. Right. And the D is here, that X coordinates are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 and 1 and 2 minus 2. 13 minus 2 are the D coordinates, right? So now we have the B and D vector. Now let me find the coordinate, the column vector EB. Okay, so the vector EB is OB minus OE. So OB we just got is 3, 4. Let me write down as a column vector. Minus OE is the midpoint, that is 8, 1. So 3 subtract 8 is minus 5. And 4 minus 1 is 3. So the column vector EB is minus 3, minus 5, 3. And what is ED? That is OD minus OE. OD we just got, that is 13 minus 2. Subtract 8, 1. 13 minus 1 is 5. And minus 2 minus 1 is minus 3. So that is 5 minus 3. This is the column vector for ED. Question number 7, DAB. DAB is a sector of a circle, center at A, radius is 18 centimeter. Means AB is 18 and AD is 18, right? Line CD, CB and CD are tangents to the circle. Angle DAB is 7 pi by 9 radians. Now for A part, find the parameter of the shaded region. Okay, parameter for the shaded region is this B, C, C, D and BD. This portion is shaded. So we can say that the parameter of the shaded region is basically BC plus DC plus BD. Okay, so this is BC and this BD, both are same, right? Okay, now let me find this BD. BD is arc length of this sector of a circle, right? So let me use the formula for arc length. Arc length of sector of a circle DAB is r theta. Radius is 18 times theta is 7 pi divides 9, right? So 9 times 1 is 9, 9 times 2 is 18 and 2 times 7 is 14 pi. That is arc length, or we can say this is BD. Right, we have BD. Now BC and CD both are same. So let me find BC, or CD, you can do anyone, because this is also a 90 degree, because tangent is always perpendicular to the radius, or we can say the diameter of a circle. Okay, so this is a right angle triangle. If we consider this triangle ACD, it is a right angle triangle, right? And this side AD is 18 centimeter. And what is this angle? This angle is half of 7 pi by 9. That is equals to 7 pi divides 18. Right, so we need to find this side. So this is angle, the front is opposite, this is adjacent, and this side is hypotenuse. So opposite we need to find, adjacent we know the adjacent, so we can use a ratio for tangent. Yes, so we can say that tan of 7 pi by 18 is opposite over adjacent. Opposite is DC over adjacent is 18, right? So from here DC is 18 tan 7 pi by 18. So let me calculate it. It must be in radians, right? So my calculator is already in the radians. 7 pi divides 18. Tangent of answer and then times by 18 is this. This is 49.5. 5, just round to one decimal place. So this side is 49.5 centimeter. This side is also 49.5 centimeter. Right, so let me find out the parameter by substituting the values here. This side is 49.5 plus 49.5 plus 14 pi. Right, so this value multiplying by 2 and add 14 pi. So we have 142.8, or we can say the parameter is 143. Sorry, 143 centimeter is the parameter for the shaded region. Right, now moving to the B part, find the area of the shaded region. Okay, so we need to find the area for this region is shaded. So basically area for the whole shape, subtract this sector, right? So let me find area of sector of a circle ABD, right? So let me use the formula for area of sector of a circle. Angle is in radians, so its formula is half r square theta. We have half, radius is 18 square, and the theta we have given is 7 pi by 9. Right, let me simplify. We have 7 pi divides 9 times 18 divides 2, that is equals to 126 pi. This is area for the whole sector, right? So I would like to find area for the upper triangle and subtracting this sector, and lower triangle subtracting this sector, and then we will get the shaded area, right? Let me find it separately. So for separately we need to divide it by 2. So this is 63 pi. Okay, so it means for this sector its area is 63 pi, and for this sector its area is 63 pi. right? So let me consider one triangle, the upper one or the top or the bottom, this is up to you. So if I consider this triangle, this is a right angle triangle, let me find the area for this triangle ADC, and then subtracting the area of this sector, because sector is not shaded, right? So it is half base times height, this is base and this is the height, right? So area of a triangle, area of triangle ACD, right? So this is half, base we got is 49.5 and the height is 18, right? So 18 times 49.5 divides 2, that is 445.5. So this is the area for this triangle, but in this portion of the triangle this sector is not shaded, so we need to subtract 63 pi, right? So the shaded area, or we can say half shaded area, because we are doing the bottom one, the bottom half of this shaded area. Half shaded area is 445.5, subtract 63 pi, minus 63 and pi, this is equals to 247.5, right? So this is the shaded, the bottom shaded area. So to find the top shaded area, just multiplying by 2, we will get the total shaded area, right? So the total shaded area is just times by 2, 2 times of 247.5. So just times by 2, that is 495.1, just 495 you can say, 495 centimeters square. Question number 8, a particle moves in a straight line so that t seconds after passing through the fixed point O, its velocity v meter per second is given by this. Okay, now for A part, find the distance between the particle's two positions of instantaneous rest. Okay, so we need to find the positions of instantaneous rest first. So the particle is at rest, it means its velocity is 0. So basically we need to find the two values of time when the velocity is equals to 0. So let me substitute then we will do the distance, right? Okay, so when the velocity is 0, 3t square minus 30t plus 72 equals to 0, right? So let me divide throughout the equation by 3. So 3 divides 3 is 1, so we have just t square. 30 divides t is 10t, and what is 72 divides 3? 24, plus 24 equals to 0. So this is a quadratic equation in variable t. 1 times 24 is 24, and 4 times 6 is 24. So let me break the midterm. T square minus 4t minus 6t plus 24 equals to 0. Let me take t common, t minus 4. Taking minus 6 common, we have t minus 4 equals to 0. So here we have t minus 4 and t minus 6 equals to 0, right? So we have two values for the two values of the time when the particle is at instantaneous rest, at t equals to 4 seconds and at t is equals to 6 seconds, right? Okay, find the distance between the particles' two positions of instantaneous rest. So these are the two positions of instantaneous rest. Now we need to find the distance. So we have given the velocity. How can we find the distance? So distance is the integration of velocity, right? So distance is equals to integration of velocity with respect to time, right? So let me integrate this velocity. We have 3 as it is. T square is t cube over 3 minus 30 t square by 2 plus 70t plus constant of integration, right? Okay, so for constant of integration, how can we solve the constant of integration? As we know that this is the distance, right? So we use the condition that when time equals to 0, distance traveled equals to 0. This is obvious. condition that when the time is 0, there is no distance traveled, right? So putting t equals to 0, t equals to 0, t equals to 0, distance equals to 0. So from here the constant of integration is equals to 0, right? So we got the distance is equals to t cube minus 15t square plus 72t. Right, now let me find the distance when the time is 4 seconds, right? So d at t equals to 4 cube minus 15 times 4 square plus 72 times 4, right? So let me simplify. We have 4 times 4 times 4, that is 4 cube, minus 15 times 4 times 4, and plus 72 times 4. So this is 112. This is the distance at 4 seconds. Time distance as time equals to 4 seconds. Now let me find the distance when the time is 6 seconds. 6 cube minus 15 times of 6 square plus 72 times of 6. Okay, so we have 6 cube minus 15 times 36. 6 square is 36 plus 72 times of 6, that is 108. Okay, now let me find the distance between the particles to position of instantaneous rest. Distance between, it means we need to find the difference of the two distances, right? So with this and this, so we can find that 112 subtract 108. What is the distance? 112 minus 108, that is 4 meter is the distance, because velocity is in meter per second, so this is in meter, unit is in meter, yes. So 4 meter is the distance between the particles, two positions of instantaneous rest, right? Now moving to the B part, find the acceleration of the particle when the time is 2. So we have given the velocity is equals to 3t square minus 30t plus 72. Right, we need to find acceleration first. Acceleration is the derivative of velocity with respect to time, right? So let me find the derivative of this velocity. 2 times 3 is 60 minus 30, because the constant derivative is just 0. So we need to find t equals to 0. So acceleration at time equals to 2. 6 times 2 is 12 minus 30, and 12 minus 30 is 12 minus 30, that is equals to, let me check, 12 minus 30, I guess 18, yes, negative 18 meter per second square. That is the acceleration. Question number 9, solve the following simultaneous equations. Okay, so as you can see from the second equation, this is my second equation. If I can say that x, let me solve x value. X is equals to minus 4 divides y, right? Let me substitute this x value into my first equation, right? So we have 4 times of x square, that is minus 4 by y whole square, plus 3 times x is minus 4 by y into y plus y square equals to 8, right? So this is 4. 4 square is 16 divides y square, right? And we have y is cancelled with y. We have 4 times 3 times 4 is 12, minus 12 plus y square equals to 8, not 18, sorry. Now 4 times of 16 is 64, yes, 64. 64 by y square plus y square is, let me shift this over here, minus 12 minus 8 equals to 0. So 64 by y square plus y square minus 20 equals to 0. Now let me take y square as an LCM, and multiplying over here, that would be 0. So we have 64 plus y power 4 minus 20 y square equals to 0, right? This look like a quadratic equation. So if I can say that let u is equals to y square, right? We suppose the variable u as a y square. So this is going to be u square minus 20u plus 64 equals to 0. Now this is a quadratic equation in u. So we have 64, and we break the midterm, and we know that 4 times 16 is 64, and 4 minus 16 is minus 20, yes. So u square minus 4u minus 16u plus 64 equals to 0, right? Let me take u common. we have u minus 4 minus 16 is common, u minus 4 equals to 0. So the factors are u minus 4 and u minus 16 equals to 0. So here u equals to 4 and u equals to 16, right? Let me substitute back. U is y square, right? So here y square is equals to 4 and y square is equals to 16, right? To get the value for y, we need to do the square root of 4, y equals to plus minus 2, and square root of 16, y equals to plus minus 4. Right, now we have 4 values for y, plus minus 2 and plus minus 4. Now let me substitute these values one by one into this equation to get the values for x. Right, so y equals to plus minus of 2. Right, so x is equals to minus 4 divides plus minus 2. So 2 times 1 is 2, 2 times 2 is 4. So that is plus minus 2 you will get. So at y equals to plus minus 4, x is equals to minus 4 divides plus minus 4. This is again plus minus 1. Right, so we have 4 values for x and 4 values for y. So we can say that xy is equals to where are the x values? So yeah, when this is plus minus 2 and plus minus 2, and we have plus minus 1 when y is plus minus 4. So these are the values for x and y. Question number 10, in a part, find the integration for this function. Okay, this is an exponential function. Let me simplify this first. So e power x plus 1 whole cube. So we can say e power 3x plus 3 dx. So the integration of e power x is just e power x. So e power 3x plus 3, and the derivative of 3x plus 3 is 3. So dividing it by 3 plus the integration constant. Right. Now for the b part, in one, differentiate with respect to x, y equals to x cos sine 4x. Okay, derivative. So dy over dx is equals to, we need to use a product rule here. So first term as it is, the derivative of the second term, derivative of sine is cos 4x, and the derivative of 4x is 4, plus second term as it is, sine 4x is as it is, derivative of x is 1. So we have 4x cos 4x plus sine 4x. Right, now for the third part, hence show that the integral, this definite integral is equals to this. Okay, so let's do the integration. It's again a product rule of integration. We use a by parts. So 4 is outside. Let me use this integral, indefinite integral. We have x cos 4x dx. At the end I will substitute the upper and the lower limits, right? So let me use by parts here. So we have 4. Okay, so the first function, let me take x as a first function because the derivative of x is just 1. So x is a first function, integration of second function, minus whole integration, derivative of first function, integration of second function. Right, so now we have 4, and here we have x, integration of cos is positive sine. So we have sine 4x divides 4 minus integral, this is 1, and again sine 4x divides 4 dx. Right, okay, so we have 4, here we have x by 4 sine 4x minus 1 by 4 is outside, and the integration of sine is cos, minus cos 4x divides 4. I'm not adding constant of integration because I have to use the definite limits. So let me put the limits, my pi by 4 to 3 pi by 3, yes. Right, so let me multiply with the 4. So we have x sine 4x over here, and negative times negative is positive, 4 is cancelled with 4, cos 4x by 4. Now we have to substitute the limits, pi by 4 to pi by 3. Now let's start with the upper limit. So we have pi by 3 sine 4 pi by 3 plus 1 by 4 cos 4 pi by 3 is the upper limit. Subtract the lower limit, means both are negative. Pi by 4 sine 4 pi by 4 minus 1 by 4 cos 4 pi by 4. So 4 pi by 4 is just pi, right? And we know that sine of 180 is 0 and cos of 180 is minus 1. 4 pi by 3, 4 pi divides 3. Sine of 4 pi by 3 is minus square root of 3 by 2, and pi by 3 is outside, times we have pi divides 3. That is, or just let me keep it as it is. Yes, pi by 3, and this is minus square root of 3 by 2 plus 1 by 4. What is cos 4 pi by 3? 4 pi divides 3. Cos of answer is minus 1 by 2. This is minus 1 by 2. Let me double check sine pi. Sine of pi is 0 and cos pi is minus 1. So minus 1 by 4 times minus 1, right? So let me simplify this further. This is minus square root of 3 pi divides 6 minus 1 over 8 plus 1 over 4, right? So 1 by 4 plus 1 by minus 1 by 8. 1 divides 4 minus 1 divides 8 is 1 by 8. So this is equals to 1 by 8 minus square root of 3 pi divides 6. So this is exactly the same we got. That is 1 by 8 minus pi square root of 3 by 6. This is equals to my right hand side. Question number 11. In this question, all lengths are in centimeter. Okay. The volume and surface area of a sphere of radius r are 4 by 3 pi r cube is the volume of a sphere and 4 pi r square is the surface area of a sphere respectively. The diagram shows a solid object, right, made from a hemisphere. This is the hemisphere of radius r and a cylinder of radius r and height y. The volume of the object is 500 centimeter cube. We have given that the volume of this object is 500 centimeter cube. So as we know that this whole volume is made up of volume of a cylinder and volume of a sphere, hemisphere, right? So volume is made up of volume of cylinder plus volume of hemisphere, right? So the volume is 500 centimeter cube. Volume of a cylinder is 4 over volume of a cylinder is just pi r square h plus volume of hemisphere, as we have given at the top that volume of a sphere is 4 by 3 pi r cube, and for hemisphere we need to divide it by 2, so that is equals to 4 by 6. 3 times 2 is 6 pi r cube, right? So we have 500 equals to pi r square h plus 2 by 3 pi r cube. Let me solve the value for, okay, sorry, x over here, the radius is x and the height we have given is y. Replacing the variable x, r with x and h with y. Okay, and let's solve for the y. So now 500 is equals to pi x square y plus 2 by 3 pi x cube. Okay, so the value for y is 500 minus 2 by 3 pi x cube, and then we have times 1 by pi x square. This is the value for y from the given information. Now for a part, find an expression for y in terms of x. Show that the surface area S of the object is given by this. Okay, so we need to find the surface area of this object. It means the surface area of hemisphere and the surface area of a cylinder, right? Okay, let me use this information. The total surface area. Surface area, that is surface area of hemisphere plus surface area of cylinder. Okay, so S is a surface area. So the surface area of hemisphere we have given like at the top. The surface area of sphere is 4 pi r square, and for hemisphere dividing by 2, so that is 2 pi r square. 2 pi r square plus we have given the okay, and the surface area of a cylinder has a formula 2 pi r square plus 2 pi r h. Okay, we use 2 pi r square when we have upper and lower, we both have the circles, right? The upper surface of cylinder is circular and the lower is also circular, but as you can see, this upper portion is covered in hemisphere, right? So we are not using 2 pi r square, we are just using pi r square, right? This is a reason we are using. So 2 pi r square is a surface area of hemisphere. Now for cylinder, we are using 2 pi r h plus pi r square, right? Why pi r square? Because the upper circular portion of a cylinder is covered in the cylinder hemisphere, right? Now S is equals to 3 pi r square plus 2 pi r h. Again, we have to replace the variable x with r with x and h with y, right? So after replacing, we will get the surface area is 3 pi x square plus 2 pi x y, and we have to solve the value for y, substitute the value for y, as we know that the y has this expression for y, we just got it. So let me substitute the y expression here. So s is equals to 3 pi x square plus 2 pi x, and the y is divided by pi x square 500 subtract 2 by 3 pi x cube, right? So okay, 3s is equals to 3 pi x square. Let me simplify it now. So now we have pi is cancelled with pi, this x is cancelled with this x, so 2 by x we are left here. So plus 2 by x is multiplying with 500 minus 2 by 3 pi x cube, right? S is equals to 3 pi r square plus 2 times 500 is 1000 divides x minus 2 times 3, 2 times 2 is 4 by 3 pi x is cancelled with this to x square, right? So now how many x squares we have? Pi x square 3 and minus 4 by 3. So let me solve this. Minus 4 divides 3, add 3, that is 5 pi 5 by 3. S is equals to 5 by 3 pi x square plus 1000 divides x. So we got exactly the same, that is 5 by 3 pi x square plus 1000 divides x. Now for part B, given that x can vary and s has a minimum value, find the value of x for which s is a minimum. Okay, so s we got from the A part, that is 5 by 3 pi x square plus 1000 divides x. Okay, so to find the minimum value of s, we need to differentiate the s with respect to x and put it equals to 0, right? Basically finding the critical points. ds over dx equals to 5 by 3 pi, this its derivative is 2x, and minus 1000 divides x square. So 1 by x derivative is minus 1 by x square. Okay, now further simplification, 2 times 5 is 10 by 3 pi x minus 1000 divides x square, right? Now what we have to do, we need to substitute the first derivative of s with respect to x equals to 0 to find the minimum point, the minimum the value of x at which s is minimum, right? So let me solve for x. So this is 10 over 3 pi x equals to 1000 over x square, right? Now let's do a cross multiplication. This is multiplying here, so this is x cube, and we have 1000 divides 10 by 3, 10 pi by 3. right? And x cube is equals to 1000 times 3 over 10 pi, right? And 0 is cancelled with 0, so 300 by pi. X cube is equals to 300 divides pi, and the x value is cube root of 300 by pi. So this is the value of x at which s is minimum. Question number 12. Do not use a calculator in this question. The diagram shows part of the curve, this curve, and part of the line, this line. The curve meets y-axis at point A. Okay, the curve meets y-axis at point A. So it means at y-axis. So the y coordinate equals to the x coordinate is equals to 0. So when I substitute x equals to 0 over here, so it is just 1 by 1. So the x is 1. X is 0 and the y is 1 here, right? The line meets x-axis at point B. So this is the line at meet the x-axis. It means the y value is equals to 0. So 0 equals to x minus 1. So x equals to 1. X is 1 and y is 0. The line and the curve meets at point C. So both this line and the line and the curve both intersect at point C. We need to find the coordinates for C. Let's see. Now for the A part, find the coordinates for A and B. So we already did 0, 1 and 1, 0 are the coordinates for A. So A is 0, 1 and B is 1, 0. Right. Now for the second part, verify that the x coordinate of C is 2. Okay, so as we know that the C is the point where the curve and the line intersect. So here we have y value. Let me solve the y from here. That is x minus 1 by 5. So just compare the two values for y and solving for x. So we have 1 over 2x plus 1. This is equals to x minus 1 by 5. Cross multiplication, we have 5 equals to x minus 1 into 2x plus 1. Right. Okay, we have 5 equals to 2x square and plus x minus 2x minus 1. So 0 equals to 2x square minus x and then minus 6. Right. So this look like a quadratic equation. So let me do the factorization. 2 times 6 is 12. 4 times 3 is 12. Yes. So we have 2x square minus 4x plus 3x minus 6 equals to 0. So 2 is common and x is common. We have x minus 2 plus 3 is common, x minus 2 equals to 0. So the factors are 2x plus 3 and x minus 2 equals to 0. So let me substitute both values separately. Equals to 0, we have x equals to 2, and from here x is equals to minus 3 divides 2. Okay, so we have C is on the positive side of x. So it means x value must be positive over here, right? So here is some x value, right? So this must be positive, not negative, right? We are not taking negative 3 by 2. We can take x equals to 2. So here x is equals to 2. So now we verified that the x coordinate of C is 2. Now for the B part, find the exact area of the shaded region. Okay, so this is a shaded region. You can see you have this curve and this line. So basically we need to find the area between the curve and the line. So let me find the area under this curve between when the x is 0 to 2, right? So integration, right? So we can say area under the curve AC, right? So that is equals to integration between x is 0 to 2 of this function 1 divides 2x plus 1 dx. So 1 over x integration is natural log of x, but we have to complete its derivative into the numerator. So its derivative is 2. So let me multiplying and dividing by 2. So 0 to 2, we have 2 over 2x plus 1 dx. So here we have 1 by 2 natural log of 2x plus 1, and the limit is from 0 to 2. Now let me substitute it. 1 by 2 natural log of 2 times 2 is 4 plus 1 is 5. minus lower limits 1 by 2, natural log of 1. So natural log of 1 is 0, ln of 1 is equals to 0. So we are just left with 1 by 2 natural log of 5. Right. This is area under the curve. Right. Now let me find area under the line. Area under the line AL. Right. So this is a line we have. Again, we do the integration when the x value is between 1 to 2, right? This line, right? X minus 1 by 5. So integration of 1 to 2, x minus 1 divides 5 dx. It means 1 by 5 is outside. Integration of x is x square by 2, and integration of minus 1 is minus x, upper limit and the lower limit, right? Now let me substitute the limits one by one. 1 by 5 is outside, upper limit is 2, 2 square is 4 by 2, minus 2, minus lower limit is 1, so minus 1 by 2 and then plus 1, right? Now let me simplify this. 4 by 2 is 4 divides 2, that is 2, subtract 2, that is 0. So 1 subtract 1 by 2 is just 1 by 2, and multiply with 1 by 5, that is 1 by 10. Okay, now to find the shaded area between the curve and the line, since the curve is at the top, so we can do the area of the curve subtract area of the line. But if line is at the top, we do area of line subtract area of curve, right? So here we have the shaded area. Area of curve subtract area of line. So area of a curve is 1 by 2 natural log of 5, and area of line is minus 1 by 10. So this is the shaded area. Question number 13. The function f and g are defined for x is greater than 0. So we have a restriction on the domain that x value is greater than 0. In A part, find and simplify an expression of f composition g of x. Right. So f of g of x. So that is easy. So just substitute g of x. F of 1 by x. Now f of x is equals to 2, 1 by x square minus 1 over 3 into 1 by x, right? So here we have 2 over x square minus 1 whole divides 3 over x square. So let me take LCM. We have 2 minus x square divides x square and then times x by 3. So we can cancel x square with this x, and we are just left with 2 minus x square divides 3x, right? Now for the B part 1, given that f inverse exists, write down the range of f inverse. Okay, so range of inverse function is equals to the domain of the function, right? So as we know that the domain of function is x is greater than 0, so what is the range of the function? F inverse is greater than 0, right? So we can say this is f inverse is greater than 0. Now for the second part, show that f inverse equals to this, where p, q, r are integers. Okay, so this is f of x. So let me solve f inverse of x. So the first step, we need to substitute f of x equals to y. So y is equals to 2x square minus 1 over 3x. Right. Now in the next step, we need to replace the variables x with y and y with x. So this is x equals to 2y square minus 1 over 3y. Right. Now let me do the cross multiplication. So 3xy minus 2y square plus 1 equals to 0. Right. So this is going to be the quadratic equation in y square. Let me take negative sign common throughout the equation. So 2y square minus 3xy minus 1 equals to 0. So this is the a term is 2, b term is minus 3x, and the c term is negative 1. So let me apply the quadratic formula here. This is a term, this is the b term, and this is the c term, right? Okay, so quadratic formula is, we can say y is equals to minus b, so that is 3x, plus square root b square. So 3x square minus 4ac, a value is 2 and the c value is minus 1, whole divides 2 times of a value, that is 2. Okay, y is equals to 3x plus square root 9x square plus 4 times 2 is 8, divides 4. So it exactly same as, so p value is 3, q value is 9, r value is 8. P, q, r are the integers, right? So that was the last question of our paper. If you have any queries, please let me know in a comment section, and please subscribe to my channel. Thank you for watching. See you next time. Take care.